Today's lesson is on constructing arithmetic sequences. This is the textbook lesson 4.2 in our HMH textbook. Your essential question is, what is an arithmetic sequence? Earlier this week, on Monday, we had our first lesson on sequences. Okay, and so we're going to keep building on what arithmetic sequences are. Our learning goal today is that I can identify a rule for an arithmetic sequence that models a situation. All right, so right here we have this example for this website, flixtickets.com. You can buy tickets online. This is a website, and so we're just looking at, how this might apply to real life, exploring arithmetic sequences. You can order tickets for the local theater online. There is a fee of $2 per order. Matinee tickets cost $10 each, and the total cost in dollars of ordering N matinee tickets online can be found by using C of N. So they're using the letter C here because we're talking about cost, all right? But this is also function notation. So if I had F of N here, it would be like the same thing. And this is C of N is equal to 10 times N, where $10 is the cost of each ticket, N is the number of tickets, plus 2, because there is that $2 fee per order. So we can take the website's way of charging you and put it into a function, and then below there's a table that shows the cost of 1, 2, 3, and 4 tickets. So the amount of tickets are N is the integers starting with 1, 2, 3, 4. So we're going to complete this table of values for the cost of N equals 10N plus 2. For if you buy 1 ticket, how much money would that cost? If you buy 2 tickets, then how much money would that cost? All right, so with your Pear Deck tab, okay, you are going to write on this slide. You can use the drawing tool, you can use the text typing tool, but you're going to fill in this table. Okay, you're going to have to put a value here. And so we'll do this first one kind of together just so you see how this works. So if the number of tickets is 1, and I put a 1 where C of N is, that means 10 times 1 plus 2. Okay, 10 times 1 is 10, plus 2 is 12. So the total cost is $12. And this is the poll question, very similar to the poll question that I gave you. Okay, it's the same idea. We're just evaluating the function for different amounts of tickets purchased. So you're going to fill in these boxes. And then also, what is the domain of the sequence? So I'm having you do 2 things here, filling in the total cost, the rest of the table, and listing the domain. We talked about domain and range of sequences on Monday when we did that lesson. Okay, so what you're going to do is, right now I have 3 of you so far that have started writing. Everyone needs to start writing and put something down. If the only thing you can do is put a 12 right here where I told you 12 goes, then do that. Okay, if you don't at least do that, then you are not even engaged in what's going on, and that's going to reflect on your attendance. It's going to go in areas that you are non-responsive. Okay, so I need you to be responsive. I need you to participate. If there's an issue with why you can't do that, then you need to write me on GoGuardian. Question came up in the chat. Do we take notes? You will be taking notes. Don't worry about taking notes right now. I don't want you, spending your time writing. Right now, I want you just focused on the Pear Deck lesson and participating with us. I am going to give you the entire asynchronous time to take notes today. Okay, so if you look at our week at a glance, your async time, you have 45 minutes later on, okay, where all you need to do is take notes. Okay, so don't worry about taking the notes right now. Right now, you're just participating and working on trying these slides. I'm up to 9 of you that have participated so far. You have started writing. If you have any technical difficulties, just write me on GoGuardian and I'll respond back to you. Okay, so everyone should be writing something on this Pear Deck slide. I have 12 out of 21 responses. So thank you to the 12 of you that are participating. Okay, you're not going to learn this material by being a passive learner. You have to participate or it's just going to go right over your head. All right, so let's take a look at what we're coming up with. Okay, so this person has the correct numbers in the table, but we don't want to put the n there actually. And they are looking for a pattern, which is good, but that is not the domain actually. Okay, total cost here, a little bit off on our calculations, but 12 is correct. 12 is correct. Okay, the second one's not going to be 24 because if I plug a 2 in where the n is, 10 times 2 is 20, and 20 plus 2 is how much? Not 24. I'm confused. Okay, well, at least you're communicating and you're here with us. 22, this is what we're looking for. So 22 is the second value in our table. The first value is 12, the second value is 22. And the third value, so you're gonna take 3 and you put it where the n is, okay? So 10 times 3 is 30. 30 plus 2 is what goes in this box here. So let's see. 32, right here, 32. That's good. This one looks good. And then for n equals 4, if I buy 4 tickets, well, this function tells me that I have to pay $10 for each ticket. So it's 10 times 4, which is 40. And also, I have to add on that $2 fee that they charge when you make an order. So it's 40 plus 2 or 42. These are the numbers that you should have in your table. And then the domain of the sequence. Remember, we talked about this on Monday when we're looking at the domain of a sequence, and that sequence is also a function. It's your inputs. So what were the values that represented the inputs? Which row was the inputs? Which row is the outputs? The domain, that's your inputs. So what were your inputs? Let's see if I can find someone who has it. The domain is the, don't say bottom row. So here, I'm going to show you guys. You'll be able to come back to these slides and edit your responses once I put you on student pace mode. But for right now, I'm going to move everyone forward to the next slide. And so here you can see that 12, 22, 32, 42, those are the values. And then the domain of that sequence, okay, your input values, what were the different values of n? 1, 2, 3, and 4. These were the inputs or the domain. The outputs or the range, well, that's what question B says. What is the range of this sequence? Okay, this value, the domain and the range, come from this table. So if the domain is 1, 2, 3, 4, the range is what? That would go here. We're gonna list that out here. And then part C, What is the first term? The first term. We talked about what that means. And then you're going to find the difference between each two consecutive terms in this sequence. So you have just 3 subtraction problems that you're going to do here. So I'll give you a few minutes to work on this slide. You should be in your Pear Deck tab or your Pear Deck window, and you should be answering as much as you can. So again, this is a draw anywhere on here slide. So what is the range of the sequence? You put here. What is the first term of the sequence? You would put here. And then find the difference between each two consecutive terms in the sequence. Everybody should be able to do 22 minus 12. Okay, everyone should be able to subtract 2 two-digit numbers. All right, this is something that anybody can do. You can do this. All right, so even if this B and C are a little bit confusing to you, you can start with D. All right, so everyone should be participating. I have 4 of you participating so far. So I'm up to 13 of you have started participating out of 22. So, you know, joining the meet, that's the first thing you got to do, right? And 24 of us were able to do that. So that was the first step. Good job. You attended the meet. Then you have to join this Pear Deck. 22 of us were able to do that. 2 of you did not join the Pear Deck for some reason or another. And of the 22 of you in the Pear Deck, 15 of you have started responding. Thank you to the 15 of you. That's exactly what you should be doing. But the other 7 of you that haven't started responding yet, this is troublesome. You have to participate. You're not going to learn this stuff unless you try it. All right, so let's take a look at some of the responses we're coming up with. So the first question, what is the range of the sequence? Here we go. This is what we want. The range of the sequence is 12, 22, 32, 42. This is absolutely correct. This is what you want for the range of the sequence. Next question, what is the first term in the sequence? What is the first term in the sequence? 12. 12 is correct. Okay, good. The first term of the sequence is 12. And then find the difference between each two consecutive terms in the sequence. Well, this is the subtracting part that I told you guys. Everyone should be able to do this part at least. Every time you subtract, look, you're getting the same number. You're getting 10. And so this difference that we're getting constantly over and over again, this is the difference of this sequence. And this is some vocabulary that's going to come up in our next slide. We're going to be talking about the common difference. All right. So you will have a chance to go back and change any answers you need to or add to this, but for right now, I'm going to move us all forward to the vocabulary slide. And so here's our vocabulary terms. One of this is repeated from Monday. So arithmetic sequence, okay, that's on here again, but I did define it a little bit differently. So an arithmetic sequence I wrote is the difference between consecutive terms is always equal. Okay, maybe I said that a little weird. It's where the difference between consecutive terms is always equal. All right, so we define this a little bit differently on Monday. On Monday, and just to be consistent with what I'm trying to point out to you, go back into that lesson. I'll go find that definition. Okay, so right here, this is how we defined it on Monday. An arithmetic sequence, the difference between one term and the next is a constant. Well, that's the same thing as we have in the presentation, okay? The difference between consecutive terms is always equal. It's always the same number, so it's phrased a little differently. In other words, we just add some value each time onto infinity. All right, and that's exactly what that says here too. Okay, so this goes on forever. It can, where the difference, and we're talking about what that difference is, the common difference is basically what you're adding each time. And so the common difference, or what you add each time, is the difference between consecutive terms. And it has its own little special variable, lowercase d, right? And so we saw here, the difference on this last one turned out to be 10. 10 was what we were adding each time. And even back here on, I think this slide, somebody came up with that, if they still have it. Yeah, goes up by 10. So they figured out what the difference was of the sequence. Okay, that wasn't the domain, but they did figure out the difference. All right, and then the other two terms we're going to look at here, explicit rule and recursive rule. So this is really big about today, these two different types of rules. And I put a blue box around explicit rule. And throughout the presentation, you're going to see there is a blue box around it every time it shows up. Right? And then I'm using a green box around recursive rule. And so these are similar, but they're different. They're both rules for sequences, whereas an explicit rule, the nth term of an arithmetic sequence is defined as a function of n. A recursive rule, the first term of the sequence is given. So you will be given f of 1 equals something, or whatever the first value is. And then the nth term is defined not as a function of n, but by relating it to a previous term. So this is the recursive type of rule and the explicit type of rule. When you write a sequence, and you're trying to write the rule of a sequence, you can write an explicit rule and you can write a recursive rule. You could write it either way and they will both work. And so we're going to look at both types. So here's an example. We are going to write a recursive rule, green box, okay, and an explicit rule, blue box, for the sequence described by each table. All right, and so back here, recursive rule means I have to know what f of 1 is and relate it to a previous term. Explicit means it's a function of n. So the table shows the monthly balance in a savings account with regular monthly deposits. The savings account begins with $2,000 and $500 is deposited each month. So in this table, we have time in months. These are our ends. These are our inputs. This is our domain. All those things mean the same thing. Starting with 1, 2, 3, 4, 5. These are integers, okay? They increase by 1 as we go up. And balance, this is a function of n. This is the outputs. This is the range. This is the sequence. So we get 2,000, okay? Then we have 2,500. Then we have 3,000. Then we have 3,500. Then we have 4,000. So say we want to know way down the line in 5 years how much money is going to be in our account, in 20 years how much money is going to be in our account. Okay, it would get tedious to keep writing this out over and over again. Okay, 12 months in a year, so 5 years, it's like 60 times you'd have to write something out. Or if you wanted to go 20 years in the future, it'd be 240 like calculations you'd have to do. You wouldn't want to do that. So that's why we have these sequences that we can write as a function. And then that way we can figure out things further in the future using a formula. Okay, so the recursive rule, which is where we have to define f of 1. That's what we have here. F of 1 equals, so in the first month, we have 2,000 because the account begins with 2,000. So f of 1 is equal to 2,000. For either type of rule, recursive or explicit, you're going to have to figure out what's the common difference. What are we adding each time? Or what is the difference between 2,000 and 2,500? What is the difference between 3,500 and 4,000? It's always the same amount being added each time in a sequence, and here the difference is 500. Okay, and that is because $500 is deposited each month. And so our recursive rule using this information is f of 1 is equal to 2,000. Okay, so we have to define what f of 1 is. And then f of n, okay, is going to be equal to f of n minus 1. So it's the function of the term before this term, right? If n is 4, then n minus 1 is 3. If n is 18, then n minus 1 is 17, plus 500 for n greater than or equal to 2. So this is our recursive rule here. For an explicit rule, then we're thinking of it a little bit differently. Okay, so d, our difference, lowercase d is difference, is always multiplied by a number equal to n minus 1. You can generalize the result from the table. The explicit rule is f of n. So we don't have to define f of 1 in this case. It's f of n is equal to, I could figure out any value in the table anywhere I want just by doing this rule here, which is you start with 2,000 and you add 500 multiplied by n minus 1. So if I wanted to know, and I keep moving my mouse and it covers it up. I'll stop moving my mouse. If I want to know at 100 months down the line how much money is in the account, well, what I could do is f of 100 is equal to 2,000 plus 500 times n minus 1, 99, 500 multiplied by 99 plus the $2,000 that you started with. Okay, so this rule helps you figure out things way far in the future. And both of these would work. Okay, it's just they're two different ways. All right, I know it's a little hard. It's a lot of information being thrown at you. So what I want you to do right now is you have an interactive slide and you have two dots. You have a green dot and you have a blue dot. The green dot is for the recursive rule. Drag it over the example of a recursive rule. The blue dot is for an explicit rule. Drag it over the example of the explicit rule. You have one of each. Have 8 of you that have responded. Thank you. 11, 12 of you that have responded. Thank you. We're up to 13, 15. If you're confused right now, it's okay. Look at these two examples. What do you notice that's different about them? Okay, and the differences are the things that make it explicit or recursive. We're up to 17 responses. Oh, guys, we could get 23 responses. We are so close. I just need 6 more of you. You can do it. We're really close on how many people are supposed to be in the pair deck because there's 24 students and we have 23 of you in the pair deck. So only 1 student didn't join, which is pretty good. Pretty good odds. I would like if everyone was here, but I don't see the 17 getting any higher. So let's see. We are split. And that just means you're confused still, and that's okay because we're still learning this and it's something that's new. I'm gonna hide that. Let me ask you this. What do you notice that's different about these 2 examples? Anybody want to put it in the chat or say it? You notice anything different?
One has more of the equation.
It does, absolutely. And if you look, this one has f of n, this one has f of n, this one has f of 1. There's only one of these type that has an f of 1 in it, that we have to have f of 1. I'm going to go to, well, no, let's not do that because then it's going to mess up. No, I can do that. Sorry, I'm just chatting with myself as we're going through this. Okay, which one do we have to define the first term of the sequence? Explicit or recursive? First term of the sequence is given, which means f of 1 is given. So if you see an f of 1 equals and then they tell you a number, that is a recursive rule. So recursive rule, green dot over here. Explicit rule, blue dot over here. You guys notice anything else different about if you look at f of n equals and then what you see here versus what you see here? Is there something different about these 2? Numbers are in different spots.
There's 7.
That's true. One has 7.
The 7 is in the different, and so is the F.
F. The F is the one that I was looking for you guys to notice. So right here, this is a function. This is the function rule. So this function is defined by a function within a function. That's the recursive thing. Okay? You have to know something before to get the next thing. For over here, this one does not have any f's on the right-hand side. There's no function of anything. There's n minus 1, but that just means I subtract 1 from whatever number this is. If this number n equals 47, well then right here in these parentheses, I'm going to put 46. That's all this means. So that function part is another giveaway that this is the recursive and this is the explicit. Okay. There is a way to come up with these rules. There's actually like this formula, okay, for recursive rules and explicit rules, and this is it. So it's almost like a cheat sheet. So if you were asked to write a general recursive and general explicit rule for each arithmetic sequence, so here's a sequence. Okay, remember we defined a sequence as, back here is just a list of numbers or objects in a special order. Today, we defined an arithmetic sequence as the difference between consecutive terms is always equal. Okay, so we're right here. All right, so this is a sequence, and it's an arithmetic sequence because the change from 100 to 88, however much, you can think of it as adding a negative since we're subtracting. Okay, how much do I subtract to go from 100 to 88? What's the difference between those 2 numbers? It's going to be the same amount each time. It's 12. I think I'm adding, you think that is the difference between 188 right here, it's showing you. Okay, the common difference it's negative 12. Because these are going down and they're getting smaller, we're adding a negative amount each time. So adding negative 12, adding negative 12, adding negative 12. That's the common difference. So that's our little d that's in both of these. And f of 1 is always just, what is the value of the first term? F of 1. What's the first term in the sequence? It's 100. 100. And so if I know f of 1 for the recursive rule, all I have to do is just plug in those pieces. So if f of 1 equals 100, f of n equals, I'm just rewriting this, f of n minus 1 right here. And then I'm adding the difference. So I'm adding negative 12, which is the same as subtracting 12 for n greater than or equal to 2. The explicit rule, using this sequence and using the difference of negative 12, you just plug in the pieces. So f of n equals f of 1, the actual value of it is 100 because it's the first term, minus the difference, because instead of plus the difference, it's negative 12. So it's instead of adding negative 12, minus 12 times n minus 1, n minus 1. So all you have to do to use these general formulas or like cheats is just figure out what is the first term. In this case, it was 100. Figure out the difference. In this case, it was negative 12. And those are only two values you're plugging in to change it. All right. Multiple choice question here. Choose the correct explicit rule. Okay. And I put those cheats right here for you. Okay. So we're talking about explicit rule this time. Here's the explicit rule general formula. F of n is equal to f of 1 plus d times n minus 1. So the correct explicit rule for this table of values, you only need to figure out two things. First thing you figure out, what is f of 1? What is the first value in the sequence? Second thing, what is the difference? What's the common difference? How do I get from 8 to 12 to 16 to 20 to 24? These are going up, so I'm adding each time. What am I adding? I need to know what f of 1 is and what am I adding each time. And then I just plug them in to the general explicit rule where they go. This is multiple choice. I have 4 responses. Seven responses. We are almost out of time. I'm going to show the responses here. We're pretty split. I'm going to hide the responses. So f of 1, if n is 1, then f of 1 is 8. So I better have an 8 right here in my choice. So possibly it's A, because 8's first here. Can't be B, because I have a 12 there. B is wrong. C, it could be 8, because 8 is here. So what's different between A and C? One has a minus 1, one has a plus 1. Do we want minus or plus? Minus. Minus 1. Okay, the difference is 4. Okay, that's why the D is replaced with 4. And then it's n minus 1. So the correct answer is A. A. And then your last slide here. Same table of values. Look at that. Oops. Turn around. Same table of values, but now I want you to choose the correct recursive rule for this table of values. We already know f of 1. We already know what d is. We already know the difference. We already know f of 1. F of 1 is 8, and the difference is 4. So, using the recursive rule, choose the one that makes sense for that rule.